Okay, today we are going to have a review lesson over complex numbers. So, Algebra 2, we learned what a complex number was. We learned how to add, subtract, multiply, and divide. And that's really what we're going to do today. So, complex number. We have the number, imaginary number I, which is the square root of -1. Really what that meant is, you had a square root, something like I had the square root of -25. Well, if I put that in my calculator, it's going to say error. But I know that's the square root of -1 times the square root of 25. Square root of -1 is I. Square root of 25 is 5. So that's 5i. Really, if you had a negative underneath the radical, you brought that I out. Now, what makes a complex number? Complex number is a number that has a real part and imaginary part. So a plus bi. A is my real part. Bi is my imaginary part. Now you can see I've listed all these are examples of complex numbers. Now you have to think that the imaginary part could be 0. So, I could write -6 plus 0i. Any real number can also be a complex number, but a complex number cannot be a real number. So if it's got I, it's complex. So we're assuming that we're doing all these without our calculator, like plugging I in. We're doing it algebraically. So if I am adding and subtracting, I'm putting together the real parts and the imaginary parts, which is like terms. With adding, the parentheses mean nothing. I mean, what's 7 plus 4? 11. What's -3i plus 5i? A positive 2i. There would be my answer. With subtraction, I always talk about distributing my negative sign. So, my first one stays what it is, but this negative goes to both of those. So that becomes a -8 and a -3i. Now do what you see. 2 minus 8 is -6. -1i minus 3i is -4i. So adding and subtracting put together like terms. Multiplying. The thing we have to remember with multiplying, which is when those parentheses are smack next to each other, I squared is -1. So if I have a binomial times a binomial, I'm either foiling, which don't really say, or distributing everything in the first parenthesis to everything in the second parenthesis. So 2 times 5, 10. 2 times a -I, minus 2i. Now I take positive 3i times 5, positive 15i. Positive 3i times a -1i is a -3i squared. So then I have to remember, I squared is -1, which multiplying by -1 just changes our sign. So if you remember that, that's really when we got rid of that and changed the sign. So now put together like terms. 10 plus 3 is 13. -2i plus 15i is a positive 13i. And that's all you can do. Um, if I gave you something like this, what does it mean to square something? You cannot distribute that. What that means, if I'm squaring, I have two of them. A half plus radical 3 over 2i times a half plus radical 3 over 2i. I do the same thing. Now remember, multiplying fractions, straight across the top, straight across the bottom, even though I know a lot of you will use your calculator. A half times a half is a fourth. A half times a radical 3 over 2 with an I, 1 times radical 3, top, 2 times 2, and I still got my I. Now do the next one. Well, that's the same exact thing, radical 3 over 4i, and then radical 3 times radical 3 is actually radical 9, which is 3. 2 times 2 is 4. And then I times I is I squared. Again, that goes away. That changes its sign. A fourth minus 3/4 is negative 2/4, but that's really negative a half. And then these are like. So a radical 3 over 4 plus a radical 3 over 4, think that you have two of those. So I have 2 radical 3 over 4 i's, which again is a half. 1/2 radical 3i. That's a little bit harder with fractions, but you should be able to work with those. So then division. With division, we have to get rid of the I on the bottom. So we use the conjugate. If you remember that word, the conjugate of A plus BI is A minus BI. You change the inside, not the A. So you're looking at the denominator. So you're multiplying the denominator by the conjugate, and whatever you do on the bottom, you do on the top. So if we look at this first problem, I look and I say, well, I got 3 minus I on the bottom, so I got to do 3 plus I. Whatever I do on the bottom, I got to do on the top. Now, on the top, you're just distributing. 2 times 3, 2 times I. On the bottom, you got a binomial times a binomial. So you got to think 3 times 3, 9. Now, again, if you remember anything about the conjugate, when you multiply something times its conjugate, the middle terms cancel out. So really, you're just doing the first times the first, the last times the last. If we think of that, minus 1i squared, so you get rid of that. 9 plus 1 is 10. Now, going back thinking of like quadratics when we had an answer like this, if every number in the whole entire problem is divisible by some number, you would want to do that. So 6, 2, and 10 are all divisible by 2. So to reduce that, 6 divided by 2, 2 divided by 2, 10 divided by 2. You cannot do that unless it's all numbers in the answer are divisible. So that's division. The only other thing, just remember, which we should have already gone through, if we're solving a quadratic and we get that b squared minus 4ac, which is the discriminant, to come out negative, I'm going to have I in my answer. It's going to have no real answer, which means it has no real x-intercepts. It's going to be like a parabola that's right side up above the x-axis. So again, that really is something we should have already gone through, but you do want to remember those words. So short little lesson and a little assignment, just reviewing complex numbers.